Hi, CAD 222. Looks like some of you guys are having some problems with 16.4. Here is a good example of one way for the solution. Um, you can use AutoCAD, Inventor, or SolidWorks. I'm going to show you the SolidWorks way of doing this. First of all, we need to create. Let's look at the problem. It says draw the mechanism in the position shown. Use different colors to draw the mechanism in the extreme right and extreme left position. So that being said, we know we have a normal position, which is being shown in the book, and that's with the AB link at 60 degrees. And then center to center on A and C is 3.8, and then center to center on C and A on the elevation is at 1.6. So the first thing that you need to do is draw your links. All right. What I do, I'll take a link. Let's do part 1 here. Here's the link for AB. I call this AB. We'll name this file. Save as. We'll save it as AB. All right. Hit save. Blah blah. Notice that I create a link. I have a quarter piece of plate right here with 2 holes in each end, and I follow the direction in the book, which says it needs to be at 1 inch. Right, so your AB link is at 1 inch. All right, and again, you can put a nice little radius here, which I think I've got at 1/8 of an inch. Get that drawn. All right, the next thing we need to do is look at this little guy right here. This little guy right here is important because it is a disc with a shaft on it. The disc is actually the size of the radius that the book tells you. The book says it needs to be a 1 inch. Right, because we know A and B is at 1 inch. All right, so we know that this link is going to rotate around that 1 inch. Now you can make this any size, to be honest. Because you notice that I'm not all the way out to the concentric points of link AB and BC. What this basically, this dish just allows you to go around in a 360-degree circle. AB basically guarantees that you're going to go around in a 1 inch in or 2 inch in diameter, 1 inch in radius circle. Now notice that once I get that done, I make what is a representation of a level surface, which is basically a block. So part 4 here is this can be where C is. This is the surface in which the C is going to ride on. All right, this is where we determine our extreme left, our extreme right, and our normal position. All right, so here it is, all put together in one assembly. I got my disc with my shaft. I've got my my AB, which is at a 60-degree angle at this point, and you can put a mate on there and make sure it's at 60. Speaking of mates, let's look at the mates that I have on AB. I have a concentric to the shaft on the disc. I also have a coincidence to make sure that I'm up against the disc. I have a concentric where B mates with C, where B mates with link BC, and then of course I have it laying on this surface that is a representation of just a flat surface. Alright, so here's what I've got. This is my normal position because I have this at 60 degrees. So what I would do at this point, I draw me a little center line, alright, to let's pick this plane, just to represent that's the normal position. Because what we're trying to do is establish the stroke, the distance between the extreme left and extreme right. Alright, once I get that done, I'm going to hit my check button, get out of it. Now I'm going to rotate this around. Now what's key here is that you have constrained all of these holes axis to axis to each other. And then down here at the bottom of link BC, I've actually got it constrained to the block with a tangent. So let's look at that constraint. Part 2, I should have a tangent. I think I use a tangent right here. See where it's tangent to this surface. So as I rotate this disc where A and B is at, and it pushes B and C, it pushes it along that surface that we created. Okay. So now we've established our center point, our let's say our normal position at 60 degrees. Now let's go ahead and rotate our link. Notice that you can tell when the link stops and starts to come back. That is your extreme right. Okay, so here we go. We're going, and right there is going to be my extreme right. So here's what I'm going to do. I'm going to go back to this sketch right here. I'm going to open it up, and I'm going to put me another center line to represent the extreme right. Okay, come out of it. Bingo. Now let's go back into, whoops, go back into our sketch, center line. I'll make that center line here to here. For some reason it wants to snap, so I drew a line. Alright, hit your it still wants to snap over there, so let's do this. Let's do a measurement. Since it won't allow me to do a reference, we're going to measure. I'm going to go to Tools. I'm going to measure from this point to the center of the circle. Alright, which tells me well, I'm going to draw a box here. I'll move this over to the center. Put me a relation between here and here. Alright, that's tangent. Alright, so now I have a line here. Now if I go and I do a measure, this right here is at 1.02. Now we're back on to finding the extreme left. So let's go ahead and rotate our link. Notice that there is our normal position. Alright, here is, you'll notice that the stroke was going to stop, and when it stops, right there is where we want to reference. Let's reference center there. There we go. Alright, now I can do a measure from here to here. Oop. Go back and do Tools, go to Measure, measure from your extreme left to your extreme right. And for some reason it doesn't want to. Alright, we got this measurement. Let's see if that'll stay there. Alright, now let's go and rotate this back to where we need to be there. I'm going to try to go back into this sketch and bring this over to there. And hit our check button. Close. Alright, now that is our stroke. This was our extreme right. This is our extreme left. So if I wanted to do a measure, this line, it tells me then that my stroke is 2.18 inches long. Now we've got to get all this data into a 2D representation. Well, how do we do that? Just simply go to File, Make a Drawing Of, and bring it in with the extreme, that's your extreme right, and then basically go back to your extreme left, bring it in, and then you can save this. If you want to turn this in, that's fine. Just give me the measurement on the stroke, or you can actually save this as a .dwg here, and hit save and bring it into AutoCAD. Alright, that's 16.4 and our stroke was at 2.18. So the key is that you draw your links, alright, and draw you a shaft with a disc on it that will allow your link to rotate around that disc. Alright, any questions, let me know. Thank you.